Hi everyone, I welcome you all for this lecture in IP addressing, which comes under the subject routing and switching. So let us move on to the session. So the introduction in part, we are going to discuss about what is IP addressing. So the purpose of the IP address is to enable communication between the devices across the network. So it comes under the layer 3 of the OSI model. I hope if you watched this previous lecture, we discussed about these internet layer protocols. So in this, we are using IP addresses. So IP addresses comes in two forms, that is IPv4 and IPv6. So IPv4 uses 32-bit addressing, and whereas IPv6 uses 128-bit addressing. So the role of this both type of IP addresses is to facilitate a routing and make sure that the data is delivered on the internet. For us, we are displayed here the example of an IPv4 and IPv6. IPv4 uses a decimal formats, that is the numbers from 0 to 9, whereas the IPv6 uses hexadecimal formats. So it combines with the decimal and alphabets used under hexadecimal formats. So IPv4 addressing, so it uses 32-bit addresses and it is expressed in dotted decimal formats. It comes in four octets, that is three digits separated in four decimal formats. So if we use these formats, the address space will be 4.5 billion unique addresses. So initially it was sufficient, but as internet evolved, okay, it is used in widely across in many devices. So IPv4 was considered to be a bit lagging, and people are now shifting to IPv6. So it is differentiated into network and host portions, and also it is defined by the subnet mask. So here we have five types of classes starting from A, B, C, D, E. It is based upon different. First octet is used to identify what class this IP address currently belongs to. And the one main drawback is the address exhaustion due to its limited space. The example is 172.16.254.1 and with a subnet mask of 255.255.0.0. So the IP address classes comes under five different things. So it is used for either large networks with 16 million hosts. The class B is used for medium-sized networks, which typically range up to 65,000 hosts. So here it comes under 128 will be the first octet. Class C, which we can widely see in almost all LAN networks or small networks, it begins with 192, and the Class D begins with 224, and Class E is reserved, which starts with an octet of 240. So the subnetting I4 is dividing the network into even smaller networks, that is in the form of subgroups. So why it is done is to improve efficiency, and it is helps us to manage our networks in a more efficient way. So that we employ a very secure operation. So it determines the network and host portion of the network addresses. So here the classless interdomain routings is also used. It comes under the 24 octet. For example, our IP address is divided into two subnets, and it is used for example, if we have a different departments in an organization, so different subnets may be used for different departments. In that case, it is widely used. Next comes the IPv6 addressing. So IPv4, the major problem is the extraction of address space. So we are using IPv6, which uses an 128-bit addressing, which is very huge. So it comes out with an 8 group of 4 digits. So the omit the leading zeros, so the or else continuous zeros, we may have an 340 undecillion addresses. So it also eliminates the IPv4 problem of address extraction, which we have discussed many times, and there is no need for network address translation, which is an essential in IPv4. So the type of IPv6 addresses are unicast, multicast, anycast, then link local, unique local, and no broadcast. So it identifies a single device. The multicast is sends to the group of devices, and anycast sends to any nearest devices in a group. and it is auto configured for local communication. This link local is used, and unique local is used for private networks. And whereas this broadcast is not used, we call it as the multicast in IPv6. So security in IP address is IP spoofing, where it helps us to eliminate fake IP addresses, and it also helps in eradicating the misleading IP addresses, and it uses IP secure for authentication and encryption, which is used as a native operation in IPv6, and it also uses the ingress and egress whenever we are using filtering, and it also uses the dynamic host control protocol with proper authentication. So it is much more secure and it is widely used, and slowly the entire population is slowly moving from IPv4 to IPv6. So in real applications, IPv4 is still used, but IPv6 is a new technology which supports IoT, mobile devices, and even cloud services. So it is widely used. So next comes the private IP and dynamic IP. Dynamic IP is resolved at the dynamic space, and this is widely used. So in real world applications, this IP addressing is very important to identify the system which uses a unique format. So comparison of IPv4 and IPv6. So IPv4 major drawback is spacing, which is solved in IPv6, and both this IPv4 is widely used, and V6 is a new format and it is widely getting adopted. We come to this end of this session. I hope this was very useful. Let us meet in the next session. Thank you.